All right, let's get into it. Today, we're going to break down one of the great wonders of the modern world.
Seriously, how does a giant metal tube just hang out up there? Well, it's not magic, it's just physics.
To get it, you've got to know the four forces that are always acting on a plane when it's in the air.
It's basically a constant tug of war. To climb, the upward force, lift, has to be stronger than weight.
Same deal for moving forward. The engine's thrust has to beat the air's resistance, which we call drag.
Okay, so lift is the key. But this is where a really common myth comes into play. You've probably heard it.
This theory says air travels faster over the curved top of the wing to meet up at the back. Sounds logical, right?
Yeah, but it's just not true. Experts at MIT are clear there's no rule in physics that says this has to happen.
The easiest way to bust this myth? A paper airplane. The wing is flat, but it still flies. Simple as that. Okay, so if that's wrong, what's right? The real reason is actually way more simple.
It's really all about action-reaction. The wing is angled just right to push a whole lot of air downwards.
And because of Newton's third law, that air pushes the wing up. Now, another principle also helps out.
You see, the faster air over the top creates a low-pressure zone, and that actually helps pull the wing upward.
So how do pilots actually control all this lift? It's all about something called the angle of attack.
You've totally felt this. Stick your hand out a car window and tilt it. The wind pushes it up. Same idea.
So as you increase that angle, you get more lift. But there's a limit.
If you tilt the wing too much, the air can't follow it smoothly. That sudden loss of lift? That's a stall.
So yeah, the basics are pretty straightforward. But actually calculating all this stuff precisely, it's incredibly hard.
Things like turbulence, the stickiness of air, and complex airflow, they make the math a real nightmare.
And that's why, even with supercomputers, engineers still have to use wind tunnels to test physical models.
Which brings up a really interesting final question. We know how to build better planes, so why aren't we flying in them?